So yeah, my name is Carson Underwood. I'm going to kind of go over probably a lot of things you've been hearing repetitively throughout the entire conference. So I'll kind of skip through the beginning of my presentation and kind of go fast on it, because I'm going to be talking basically preparing steps for if you want to start developing an automation team or framework for the application you're testing. So I'm going to talk a little bit what some of the benefits are of automation, some of the challenges, what and what not to automate. And so those are kind of the questions you need to ask before you actually start even automating. So we'll just kind of get right into it here. Most of you probably already know what automation is, but for maybe people that are new or don't really quite understand, it really is basically taking test cases that you might want to run manually and making them run via a machine. It's not magic. It does require a certain skill set. I'm going to say this a lot. The record and playback feature is great, but you can't rely solely on that. If you rely on that and you expect to just record a test, run it 1,000 times, and it works every time, you're going to fail. You need to plan. You have to have proper processes and standards in place and a good framework for your automation effort to succeed. So some of the benefits of automation, it's consistent. If you write a good framework, you write good tests, it's going to execute the exact same way and give you the exact same results, unless the application has a defect or is changed. And those are the kind of things that you want to catch. It'll be efficient. As the amount of tests that you create increases and your runtime takes longer, throw another VM into the mix. Run tests distributed across more machines. You can, so like our framework that we use for our point of sale and our regression suite is about 2,500 tests strong, and it runs in about 3 hours. And that includes some manual prep stuff that we do. I'll get into that here in a little bit. It increases the overall coverage of the application. So you have a new feature or a bug fix release coming in that allows your manual testers to focus on the new feature and verifying the bug fixes, while the automation makes sure nothing else crept into the application. You don't have any new bugs or anything like that. So that's some of the main benefits of automation. Some of the challenges that you need to know, and as people have been talking, you need to get support from your management. That's one of the key points on here. So getting support from them, you have to make sure they understand there are challenges that come with it. You have to select a tool. You have to learn the tool. You have to learn the language for any scripting you're doing. You have to work with your development teams to make sure your application is open or instrumented. And you need to have a good feedback and relationship with your devs, because sometimes when you're trying to do object recognition, as great as test complete is, you'll run into problems. So if you're working closely with your development team, they can throw in additional properties or IDs that allow you to more easily automate your application. And then there's always going to be maintenance. Applications change, your test cases will change, your automation assets will have to change. You will have a process that you go through with that, much like developers have tasks for doing bug fixes if something is wrong in the application. If there's something wrong in a test asset, it goes through a maintenance cycle as well. So that being said, let's kind of talk about what is good to automate and what's not good to automate. That's basically the first question you need to ask, because that'll determine how your framework will work. At least initially, you can always expand later. But there's no point in creating something part of your framework for something you're not going to be testing. In general, you want to stick with heavily used areas of your application under test. If it's the login screen, for example, has been a lot of examples. Definitely, you want to have that automated. You're going to need that to even access the application. But very things that's highly redundant, data generation, data verification. If there's a high probability of failure, you definitely want to have that automated. Anything that's going to cost your company money if it fails in production. Smoke tests and regression tests are also really great for automation efforts. Some things you probably would never want to automate. If it's a single-use application, it has one cycle, one sprint, it's done, it's out. There's no point in automating tests over it. If it's very early in the life cycle of the application, the design phase where UI is still changing frequently, doing test automation and functional automation is not a good idea there. That's where you want to start your API testing and maybe some back-end testing or performance of your servers. If the UI is constantly changing, it's in flux a lot, you probably want to stay away from that, because you're going to be stuck in a maintenance loop. Every single release, you're going to have to be updating your test assets, so you're not actually gaining coverage or benefits from it. And then you definitely need to plan after you kind of know what you're going to automate and how you're going to automate it. You need to start planning on what the business requirements are. Just because you're doing QA automation doesn't mean you don't know what your requirements are. You need to make sure your tests are thoroughly covering them and making sure the application is adhered to it. You need to know your timeline and schedule, what kind of development methodology you're going to be using, agile, scrum, what your environments you're going to be testing against, what kind of data you're going to be working with. Are you going to be pulling data from databases? Is it all going to be REST services? Resources, who you're going to have on your team to help you with the automation effort. Are you going to have one person solely doing framework work and people creating tests? Is it going to be split up between your entire team? So, and then also documenting. Make sure you have a way to document everything you do. All of your automation assets should be documented, all of your utilities, how you use it. Basically, if you need to onboard someone quick to automate faster tests, there shouldn't be any guesswork. You should be able to point them to a Confluence page. Even a Word doc would be better than nothing, that shows where your assets are, how to use your source control repository, how to get data from the database, how to switch environments. That should all be documented specifically for automation, as well as whatever other team's documentation is. So I'm going to talk through, next part, processes and workflow. So it's a good idea to have kind of a workflow and process between both your manual teams and your automation teams. And so I'm going to break into kind of an example of the way we do things at O'Reilly. So our manual testing team, they receive business requirements, and 2 sprints before the release is going to have the new changes, whether it be a feature or bug fixes. They start creating test cases to ensure that either the bug fix actually worked or that the new feature works as expected. And then when we finally get the release with that change or the new feature, they run through the test cases manually once. They're passed, they go into what we call ready for automation. Then we will look through those test cases using the criteria I mentioned earlier about what to automate and what not to automate. And if it is, we approve it for automation, then we'll start automating it. It'll actually go into a ready for review status. And I'll show you a little bit of this on our sprint board too. And then it's peer reviewed at least once. If it's a younger, maybe not senior automation person, we'll actually maybe do 2 reviews. And then it becomes automated test. And our framework will actually pull from Jira our test cases and only run the tests that are in the automated test status, which is important. So say the application changes and you have several tests that no longer run because of a flow change or a backend change. You'll put those into automation modifications needed status, and then they don't get pulled from a list to run anymore. So you're not wasting machine time or analysis time for a test that you know is going to fail. So that's kind of the building. So I'm going to get into the actual meat and the fun part of this here. Is actually building a framework and utilities to share between tests. I'm going to go through quickly some examples in the PowerPoint, and then I'll actually bring up our template for our point of sale framework. So test prep and initialization. Anybody that sat in on Lino's talk yesterday using the on-test start and on-test stop event handlers, these are probably the most important things that we use in our framework. So what this does is it's going to check the application state. All of our tests start and end on a login screen. So that's a very easy way to know, okay, the application is a good state. We're not on the login screen. We need to kill the point of sale and relaunch it. We check for different variables we use for regression, like performance analysis and times, and start building a report that we email out at the end of the test as well. We set either new environments that we're going to be using. So it's a point of sale. We have several different test boxes that may be running different versions of the point of sale at any one time. And then we prepare any data that we're going to need, parts that we're going to sell in the point of sale, users we're going to be logging in with, if there's any orders we need, set up timeouts, and start building the log that we'll export out for our reporting. So data. Let's talk about data. So it's a point of sale. We sell parts. We don't want to hard code in a part number or a line code to sell in our test because that could change. We want to sell part types. So we create a class inside of our automation framework that's called part. It takes 3 parameters. This is an example. The row I'm going to use has a lot more to it. But basically, in this example, we'll take the line code, the part number, and the cost. And so then you have a different utility or function that gets the actual part from the database. And the reason you kind of want to separate this out is because what if your backend changes? What if your column names change? What if you move from an AS400 and finally upgrade to the 21st century and you're running on MySQL now? The way you're getting your data is going to be different, but the way your test interacts with it should remain the same. It keeps all of your tests reliable and consistent, and then you only have to update one spot to get your test working again. Kind of the same thing with UI actions and verifications, like we said earlier, reduce, reuse, recycle. So if you already have one utility that's working with adding something to the screen via a part or you're logging in, the way our framework works is we also include verification options in here. So if a test is actually verifying the input fields that's earlier on in the regression suite, you'll actually say, hey, let's actually verify the text here. And so it'll enter the text in the field, verify it's accepted properly, it's masked properly if you can only have numbers or only letters, or if it formats a phone number. So we're actually testing all of basically one utility for one part of your application can verify, or so, sorry, got caught up there for a minute. So after you have ran a test that does verifications, you don't need every single other test that runs to actually verify that it accepts input correctly. We've already verified that that happens. So the other test, you wouldn't say verify. You would just add the part and move on to the next part of the test, which might be verifying that you can complete the transaction and provide a tender. And so just like with the data, you kind of want to make you're kind of building your own application around the application that you're testing. So things that change in the application, you only have to change it in one spot. You don't want to have to go update every single test that you've created that adds a part to your basket because they changed that process. You want to update it once, and then all your tests that aren't actually verifying that works now. Same with data verifications. So a lot of our tests are driven by adding different types of parts to our virtual receipt on our point of sale, which I'll show you in a minute, completing the transaction with various tender types, cash, credit cards, checks, and then verifying that it writes to our backend properly. So our verify invoice data utilities take that same object of the part and an invoice number, and then we'll verify that that invoice number that we got from the actual receipt actually has the right line, the right part number, the cost, the tender type, everything that you did is written to the database correctly. So, but at the same time, we're doing it very more generic and abstracted out from the database. So that way, if something does change, the automation maintenance will be very, very minimal. And then on stop test, it's another thing. If you did any data manipulation or any kind of destructive data manipulation, restore databases back to the same point. Export your logs to a shared location. And I'll show you here in a minute too, when we send out our reports, there's a link to actually go look at the logs on our web server. So we export the logs to where they can be accessed by anyone in the company that needs it, stakeholders, project managers, developers. We update our test cases in Jira, which I'll show you here in a little bit too, and then we send out the email. And then documentation. So all of the utilities that you create, you want to have really good documentation because you're going to get to the point where you have thousands of lines of automation code. So just like development code, you want to make sure that you have it documented well and people can access it so they know what utilities are available and how to use them. If anybody in here uses JavaScript for the test complete scripting side, ESDoc is an open source documentation generator. If you use block comments in your code, you just point the tool at your source repository folder that has your script units in it, and it'll generate a web page for you that has the code automatically. Okay, so this is where I'm going to break out of the actual presentation here and kind of give you guys a little live demo. So let's see. So you can see, oh man, the resolution's kind of messed up. So this is a project template that we create. So if we're ever there's a new addition to the point of sale, we usually break those into projects. So like our tenderings are projects. We have like cash tendering, and we have a returns project. We have online order. Someone orders something on our online store and picks it up in this physical store. That's kind of how we do our test structure. But the nice thing is, so you can add this in as an existing item to a new project suite, and then you can clone the project. And so what that actually will do is give you references. A lot of people have asked, how do you use your script units across several different projects? Well, all of our script units are actually in 3 main folders here. Generic script units, so these are things like our classes, our connection utilities, and any other like things we use for our log and reporting. And then actual point of sale, so we have actions, data, catalog for our gift cards, verifications, returns. And these are all added as an existing item to this project template. So when you clone it, you get a reference to the file, not a copy of the file. So you update in one script unit, all of your projects that use that, all your tests that use that, get the update. And so the main point of the way we do things like this, and this is what I'll show you here. So let's say you're new to the team. You've been assigned a test case to basically add a random part, navigate to our tender selection screen, select cash, and say that the customer paid a full amount with cash. And you've just started, you don't know what our utilities are, but you need to find out how you're going to do that. So you can bring up our documentation page, and let's see. Oops. You can actually search for all of our different things, and oh, here, this adds a stock item. So let's see, how do we use that? Okay, it takes a few different parameters, line, item, quantity, or part info. It's a object from part info that I kind of showed you earlier. It's got verify, it's got additional parameters, and then optionally a click parameter. So are we going to be clicking on the screen, or are we going to be using just keys, keying in, tabbing, pressing the enter button? All handled by the same utility. So if the process ever changes, you still only have to update it once for any test that's verifying anything like that. So you'll go in here, and it'll tell you that it's part of the OPS folder in your project browser, or Project Explorer, sorry. And it's in the OPS actions script unit. So we can pull that over. The template, we actually have a keyword test template. The first thing or the template actually by default has getting a user type and logging in. So we're like, okay, we need to add a part to our keyword, or to our point of sale. So you would come in here and you would find, let's see. Oh. Add stock item, the one we just looked up. So you can see that we have parameters in here, but I just messed up. We don't actually have a part yet. The first thing we'll actually need to do is grab a part from our database, and basically what we check, we try to replicate real-world situations as much as possible. So we make sure that we get a part that we actually have quantity on hand out of the store. We let our databases run out of stock of items, so we're not using the same items every time we run a regression test. Every now and then we'll restock our database so we don't run out of items to test with. And you'll see this has a few different parameters as well. So I'm actually going to not bore you by dragging over a bunch of different things, because I've already created it once here. Man, I wish that was bigger. Let me try closing this. There we go. So basically, we have a test here that runs our point of sale system. It gets a user ID from their job title, so we're going to use a store manager. It performs the standard login with our user that we just got. It gets part information. It passes that part information to the add stock item. It navigates to our invoice mode. And then we're going to do one thing here. We're grabbing a value from our virtual receipt, and it's going to be the balance due. So this is going to be the amount that we're going to have to pay for at the end of the test, and we're going to save that to a local variable inside the keyword test. We're going to navigate to our tender selection. We're going to add the cache tender. We're going to wait for our screen to get back to the main screen of the point of sale, because that'll let us know that the invoice has actually been written to our back end. And then we're going to verify that we are actually back on that screen. And then we're going to get our invoice header info. We're going to store that, and then we're going to do a property checkpoint on the total that was written to the database matches what the total that was on screen. And so really you could write this test in about 5 minutes with the utilities that are provided. And then we can run it. While it's running, you'll see it's actually pulling up a Cygwin window here. So our point of sale runs on Linux servers. Well, there's not any good Linux automation tools. So we devised a way, this is another thing for the prep and planning, you need to know your environments. We actually devised a way to use our normal run scripts that the servers at the stores would use, but instead of pointing to a, no, that's not good. Instead of pointing to a Linux Java JVM, we point to a Windows 1 from within Cygwin. And I was told this test box would be good today, but it looks like it is not. Awesome. And I just got a notification my dad's trying to call me. Yeah, okay, well, I don't know why that username expired. Let me try actually reinstalling. So while this is reinstalling, I'll bring up a couple more things here that I was talking about. So when we do run our tests, I mentioned logs get exported. So you can actually come to the same website that we created, and we want to look at all of our retail test logs. So you can go back history from 2 weeks, 1 month, 3 months, all. So let's take a look at how often we've ran regression on our point of sale in the last probably 2 to 3 or 6 to 8 months. Oops, that was a newer project. So all the way back from since December of last year is when we last archived our test logs. You can see we run quite a few regressions. And they're all exported here. You can bring it up, and it'll show you the test complete test log. We actually have a cool thing, too. So if your tests are running, well, there's none right now, but it'll actually export images of the test running, too, to show live instance of all of your VMs running, so you can see where the tests are at. Nope. OK, well, you guys aren't going to get to see that test run right now. But